Okay, sure. So let's go directly to the material of our course. The name for our course is Signals and Systems. So we'll start by defining what is the meaning of a system, what is the meaning of a signal, and what is the difference between them. So let's start by defining a system. What is a system? A system is a group of components, collection of components, connected together to do a certain function. Such as what, as an electrical engineer, the simplest system that you can think about is a circuit. It's a circuit, it's a collection of resistors, capacitors, inductors, connected in a certain way to do a certain function. So a system is a collection of components, okay, connected together to do a certain function. It has an input and it has an output. So this is called a system. Okay? And a system can be electrical system, like an electrical circuit, capacitors, resistors, inductors, or it can be mechanical, like the pendulum, like the any rotor, any mechanical machine, or it can be electromechanical, like the motor, like the generator. So it can be anything, any collection of components connected together to do a certain function. For now, for our course, let's think about the system as an electrical circuit. This is the simplest system that we can think about. It has an input, it has an output. As an example, for a system, if you imagine that we have a circuit that looks like this, this is called the system. This is a very simple system that consists of a resistor, inductor, capacitor. You can consider that the input to this system, is the input voltage. This is the input of our system, and the output can be either the current, or it can be the voltage across the capacitor, let's say. So this is a system, very simple system, with an input and an output. Any system can be modeled using an equation, one equation or more. It can be modeled using one equation or a set of equations. So any system can be modeled using one or more equations. As an example, if we want to model this circuit, we say that the equation that represents this circuit is what? The input voltage equals the voltage across the resistor plus the voltage across the inductor plus the voltage across the capacitor. So we can write that V input of T equals IR plus the voltage across the inductor is LdI by T plus the voltage across the capacitor, which is 1 over C integration of I of tau d tau. So this is an equation that represents this system. And there is another equation. You can say that the output voltage across the capacitor, equals 1 over C integration of I of tau d tau. So these two equations, they represent our system, they model our system. Okay? So any system can be modeled using a set of equations, either one equation or more. So this is a simple example of a system that has an input, that has an output, and how to model this system. We use equations, usually differential equations, to represent these systems. Okay? The other definition is signals. The signals are basically these parameters that we use at the input and the output, or the parameters that change inside the system. So the parameters that change inside the system as a function of time, for example, these are called signals. Okay? So signals are parameters that change with time, and we can represent signals as functions of time. Okay, so we can represent as functions of time. Not necessarily time. Well, I'm using time as a simple example, but it can be function of anything. It can be function of space, it can be function of the location, like when I'm telling you the temperature at this point is 30 degrees, the temperature at the other point is 40 degrees, so the temperature now is a function of the location. This is called a signal. So a signal, it's a parameter that is a function of some other parameter, like a time, like location, like any other parameter. And we can represent a signal as a function. So a signal can be represented or modeled as a function. Usually in our course we will focus on functions of time, and a system can be represented or modeled as a set of equations. So this is very important to differentiate between a system and a signal. So a system is a group of components, can be modeled using a set of equations like these two differential equations, and a signal is a parameter that is used with the system. It's like the voltage, like the current, okay, and can be modeled as a function of time at least, okay? Type. Any system, as we said, it has an input and it has an output. In our course, we are going to study signals and systems. We are going to study the properties of different signals and the properties of different systems. We are going to study many transformations that will help us to analyze these signals and systems and maybe calculate the output signal from the input signal if we know the system, or calculate the system from the input signal and the output signal, and so on. The problem now of modeling, how to model a certain system using this set of equations, okay? This is a big problem that is outside the focus of our course, but usually in order to do modeling for a certain system, if you have a certain system and you want to model it like a machine or a shuttle that you are going to send to space, okay, and you want to model, this is a very complex process. You have to try to approximate this machine, you have to try to approximate this shuttle in order to try to model it accurately. And why do we do the modeling? Why would NASA, for example, before they send the shuttle to space, they model the shuttle using equations, very complex equations, and they study the shuttle before they send it? Because it's very expensive to send the shuttle without knowing what will happen to this shuttle, right? So if you send the shuttle without calculating everything correctly, the shuttle may explode in the space and you lost a lot of money. That's why they try to model this shuttle before they send it. They model it using mathematical equations. They solve everything to a great accuracy, trying to make sure that everything is correct. They simulate it before they send it to the space. They make sure that everything is correct, and then once they do that, they send it to the space. When they model, the word model itself doesn't mean it's exact model. It means that it's an approximation of the real physical system. So the mathematical model, it's an approximation. It's an approximation for the real physical system. And as we go, we try to improve this approximation by experiment, by comparing our mathematical model to the real model, comparing the results that we have from the real model to the results that we get from the mathematical equations, and if they do not match, we try to improve our mathematical model as much as possible to make it as accurate as possible. So this is with respect to the definition of signals and systems. Signals can be classified as continuous time, which means that the signal exists at all instants, or the signal is defined at all instants of time. This is called continuous time signals, okay? Or it can be discrete time. Discrete time means that the signal is defined only at certain instants of time, and this usually happens when you deal with digital systems like computers. Computers, they deal with numbers, right? A set of numbers, not with a continuous signal, Okay, so this is called discrete time signal, and this is a continuous time signal. If the system has all its signals as continuous time signals, then we call this system continuous time system. So if the system has all the signals inside it as continuous time signals, then we call it continuous time system. If the system has all the signals inside it to be discrete time signals, then we call this system discrete time system. So we have, similar to the signals, we have continuous time signals, discrete time signals. We have also continuous time systems and discrete time systems. Continuous time systems, all the signals are continuous time signals. Discrete time systems, all the signals are discrete time signals. Like in real life, some systems, they contain both discrete time signals and continuous time signals. These systems, they call it hybrid systems, and again, we will not focus on these type of systems in our course. And that's it for the definition of signals and systems. Okay.